All right, my friends, let's go ahead and get started. Tonight, we're going to implement sprays. To implement sprays, we're going to build a new component. We're going to put that on the player character that we've been working with. And we're going to do some line tracing because we need to be able to trace from our character to a wall to determine if we can spray to it. So line tracing is a pretty fundamental concept that you'll see all over the place. And in fact, like that's how you implement like a hit scan weapon. So, you know, if you want to go and implement your own shooter, this will be relevant. The other big topic we're going to cover today is decals. Let me actually pull up like an image. So decals are basically just materials that project onto another mesh. And so you can use these for like putting blood splatter on wall. You can do posters. Basically anything that like kind of dirties up a wall, decals are a good choice for that. And then you can reuse the same mesh and materials underneath it and just put stickers on top of it. So to start with, let's go ahead and build some decals, and then we'll talk about how to spray them in real time. I am going to be using tonight our emotes as our sprays. So let me go ahead and import those into the engine real quick. I'm going to start by making an art folder here, and let's make a subfolder called sprays, and let's go ahead and import our textures. And that's all it takes to import textures. So these are just PNG files. They import straight into the engine, and now we can start doing stuff with them. So the next piece that we're going to need is an actual material that is going to use our sprays here. I think, yes, there is a button. I can just create a material from a texture. So we're going to call this material spray decal. And that is going to give us a starting point. Our material right now just takes the base color from a texture sampler, which is mostly what we want, actually. I also want the alpha to go into my opacity, and I need to set the material domain to deferred decal for it to show up as a decal. So let's, why doesn't it compile? What's it mad about? Blend mode has to be translucent. That's why. All right. All decals have to be translucent in Unreal. It doesn't support opaque. Oh my goodness, I'm clicking all the wrong things here. All right, so we now have a spray decal. And I can create a decal actor. From that, I can put it in the world. So you can see this is just kind of like the placeholder image here. And in fact, you can see that blue arrow is where it's pointing right now. The reason it looks stretched and gross is because it's pointing in the wrong direction. If I turn it 90 degrees so it's facing me, you see we get kind of like this basic template material. I can just drop mine in right here. And right now it's upside down, which we don't like, but we can fix that. So looks like if I go 0 on the X direction, it's upside down, but we can bring it in there. Something that is interesting that I actually didn't know about Unreal until I was doing a little bit of prep for this. Let me see if I can reproduce it. Out of the box, if you use the defaults for decals with static lighting, they don't appear correctly in dark places. In our version of the engine, this is not true. We've made some modifications, but I didn't realize this was a behavior in base Unreal. But I'll show you what I'm talking about here. You see how right now, let's change the rotation on this guy so that he's facing the direction he should be facing. What you're going to see here is like my decal is basically invisible. You can sort of very faintly see the outline on the wall. That might not even be coming through at all in the stream. But it's not what we want. And it's because for whatever reason, they don't work with static lighting. If I put a movable light in, you'll see it shows up. But with static lighting by default, it does not. So the way we fix that on the decal is instead of doing a decal blend mode of translucent, we use debuffer translucent. And we just need color. We don't need the other parameters. So I'm going to use debuffer translucent color. And I'm guessing this has a small perf cost. Let's see here. So our stats window is going to tell us how many instructions it takes. It's actually the same number of instructions. So I haven't dug into the engine code to figure out why you need to do this, but for some reason, the default settings for decals don't work with static lighting, and probably you want them to work with static lighting. So I changed it, we recompile shaders, and now our problem is fixed. Great. I'm not going to do a missive. We're going to do something very simple tonight, Spy. Okay, so we've got our decal. I've decided that I'm lazy and I don't want to have to rotate every decal. I want it to look good when my rotation is just generally kind of facing the correct direction. So, you know, I think this level of rotation's okay, but you can see that our texture is rolled 90 degrees. So let's just fix that in the material real quick. This is a material editor. The material editor is like a special blueprint graph just for materials. And you have all these different parameters based on your shading model and your blend mode and everything else. But we're going to make a very simple material here. So I just want to rotate in my material. And I think I need, is it a texture rotator? Yes, I think this is what I need here. So I'm going to rotate our UVs. We're going to wire this up to just texture coordinates. And then I believe 0 to 1. So maybe I need like 0.25 if I want to rotate 90 degrees. Let's try this and see. So I can click the apply button. It'll apply in the world after recompiling my shader. So my shaders are recompiling. Let's see if this is right. No, we rotated the wrong direction. Let's do 0.75. I bet that fixes it. We'll apply. We'll see again here. You have a question. If you change the depth of the decal, the weird edge effect will be as wide as the depth. Yes, that's correct, Schick. All right, so now our decal is rotated correctly. I do think our big red guy here is a little bit big. We'll probably change that here. Let's make him 32 by 32 by 32. It's too small. Let's do 64 by 64 by 64. All right, so now we have a new. He's on the wall, and we can plug in whatever texture we want to here. If we want to make him a new that's eating a potato instead, like it's that simple. And in fact, I'm gonna make this texture a parameter. We're gonna use that later. Let's call this spray texture. So we'll use that later so that we can change between our texture selection at runtime. All right, so we can now place decals in the world. That's all good and well, but that's not what we're here to do. We are here to make it so that we can spray decals onto the wall. So let's talk about how we're going to do that. Well, you'll recall last time we talked about how you can add behaviors to our character by adding components. So let's go ahead and create a new component. I'm going to call it our spray component. And we'll call that BP spray component. We'll get that all set up here. We're going to open the, we don't even need to open that up yet. Let's just put it right on our character, even though it doesn't do anything yet. So we have our interactor component from last time. We're not going to mess with that today, but basically we're going to do the same thing we did last time and just put a spray component on it. And when we get a little further along, we're going to route input up to the spray component, but all of the logic to put sprays on the wall are going to flow through this new component that we're creating. And actually, I've decided that I don't want to deal with spaghetti tonight. So the other thing I'm going to do before we really get going is I'm going to turn on an additional plugin. Everything that we are going to do tonight, you can do without this plugin, but this plugin makes it a little bit nicer when you are laying out your blueprints. It's not free. I think it costs like $12 maybe. It's called Electronic Nodes. It's going to make me restart the editor. Let's save everything. We'll do that. Let me kind of show you what it looks like and why I like it. They've got an image here. So the default style for the blueprint is up here in the top left, as you can see, and that's where we get all the spaghetti. This plugin automatically lays out your blueprints in a fairly neat fashion. Electronic Nudes. No, that's not correct. All right. So I think we've now got that installed. I probably have to go and turn it on in my editor preferences. Let's see. Yes, Electronic Nodes plugin. I have all sorts of settings that we can manipulate. Let's put our settings over here and let me fire up a blueprint and I can show you what the different settings kind of look like. Let's see. I think our garage door had some logic. Let's look at our garage door real quick. Yeah, so look how clean that is now compared to if we just have it on default. I'll show you what default looks like. We can just tab between these. So you can see with default, you have all the noodles. We can do Manhattan style. It automatically lays everything out. We can do Subway style. It also lays things out. I think I want to do Manhattan, and I also want the ribbon on. You don't need to worry about all these settings, but you can play with them. Make everything look nice and clean, which is what I want. All right, so let's start writing our spray component. Line traces can be kind of complex, and I want to also use this as an opportunity to show you guys how to do debug visualizations. So the very first thing we're going to do is we're going to create a variable. We're going to call it bdebug sprays. It's just going to be a Boolean. We are going to make it editable. We are going to make it public, and I'm going to throw it in this sprays category. And every tick, if this is set, we're going to print a bunch of debug information and draw a bunch of debug information. And we'll walk through this as we go. But basically, we are going to build like some robust debug functionality so that we can see what's going on later. And if we get confused, we can fix it. And I am going to call our function draw debug information. We're going to implement this function a little bit later. Oops, don't worry about it just yet. Come back to our event graph here. If our debug mode is turned on, we're going to go ahead and call draw debug information. So the very first thing that we're going to need to do is ask a question when we want to do a spray. And that is, can I currently spray? That is going to return a Boolean, which we're going to call bCanSpray. And again, we're going to implement this function a little bit later. The other function that I think we're going to need is requestSpray, which is what our player character is going to call when we press the spray input. And the very first thing that he's going to do is he's going to check can spray. And if we can spray, we're going to go and do some stuff that we're going to implement later. The other piece that I think we're going to need is figuring out whether or not we are currently up against a wall. Because if I'm out here in the middle of the level, I should not be able to spray any surface. I want to make our player character be relatively close. And the way we are going to get that done is using a line trace. So a line trace can be fairly complex. I'll show you what the function looks like. I think we want line trace by channel here. But basically, we're going to give it a start point, an end point, a channel, which in our case is just going to be visibility. We could do other channels if we want, but we don't need to worry about that here. We can do a complex or a simple trace. A simple trace is going to be faster, so generally we prefer those. It has some debug drawing options. We're actually not going to use it here. We're going to build it ourselves. And we have this ignore self Boolean, and this is useful because it says, hey, I should ignore the component or the actor that I'm actually shooting the trace from. It returns two values. The first value is, hey, did I hit anything? And the second thing is this hit result structure. And the hit result structure has a whole bunch of information, which we're going to talk more about a little bit later. We don't need to drill too much into this, but there's a bunch of good stuff here that we can learn about whatever we hit. But before we do that, we need to figure out what are our start and end locations for our trace. So I'm making another function that computes that, and we're going to call it get line trace start and end. We are going to have that return two vectors because we need a point in 3D space for the start and the end. So let's call this line trace start, and this should be a vector. And we need line trace end, which is also going to be a vector. And you'll recall from our last gameplay programming stream, we talked about how vectors are just three floats, X, Y, and Z, right? So this is what a tech artist might do. A tech artist could do this. This is also considered gameplay programming. So, you know, designers are also going to interact with this type of stuff. Basically, anyone kind of building gameplay logic is probably going to deal with some of this stuff. So what is our start position? Well, we want to start from our character's eyes, and thankfully Unreal has a function that can tell us that. But basically we want to shoot a beam right out of our little mannequin's head and see if we can hit a wall. So let's write the logic for that first. We are on a component, you'll recall, and we can get the actor that owns us using this getOwner function. And from that, I believe it's like get actor eyes. Let's see here, eyes, get actor eyes viewpoint. This is going to be our starting location. And that's easy, right? Very simple so far. The end is a little bit more complicated because our end location, we need to start from the eye viewpoint and we need to trace forward by some distance. So let's put a configurable parameter on here and let's call this max spray distance. And we're gonna do all of our math based on the max spray distance because that is going to allow us to come in here later and change the tuning without changing all the code. I am going to default to, let's say 200 centimeters. So we'll call it 200 centimeters for now. So the next piece we need from our owner is what is the forward location? And you can get that by just asking for the forward vector. This returns a normalized vector. And what normalized means is if you take the distance of the vector, it's always going to be 1. So it has a length of 1. If you were to draw a line in the direction the magnitude's going to be 1, it's just moving across 1 centimeter in 3D space. And it turns out we can scale that to our max spray distance by just multiplying it. So if we multiply our vector by a float, we now have a forward directional vector that is stretching a length of 200 centimeters. And the last piece we need is we need to move it from that starting position. So we're just going to add that to our new vector because when you add 2 vectors, it goes from one point to the other. And I think that is going to give us a pretty reasonable trace here. We will draw it though to make sure. Let's do that. I'm going to compile, and this can actually be pure because it is only reading state. We're not writing any state. Math in Blueprint. Yes, exactly. We want to spray riot new at 5 kilometers distance. That would be too far. How do you know the unit is centimeters? Is that the unit scheme Unreal uses? Yes. Unreal's default unit is centimeters. All right, so let's figure out how we're going to draw that. Well, we have a whole bunch of debug functions here. The one that is important for this is called draw debug line. And much like our line trace, it gives us a start and an end, and it draws a line. So now that we have a function that computes start and end, let's just call it, right? And we can give the line a color. For now, I want to make it, let's say, yellow. And I'm going to change this later. I think I want it to be green if we hit and red if it doesn't. You can also specify a duration and a thickness. We're going to set duration to 0, which means it will only show up for the frame where we draw it. But that's fine because we're going to draw our debug information every single frame because we're doing this on tick. So let me show you with, right now I don't have debug information turned on, so we're not doing anything. But if I come here and if I change our debug sprays Boolean to true, we should now be drawing a line. And we are. I'm going to make the line thicker because I bet that is not coming through on the stream. So let's set our thickness to like 2 for now. We'll try 1 first and y'all can tell me if you can see it. You should now see a yellow line shooting out of his eyes. Can you see it? How does it look? Now, as I move around, that yellow line is going to move with our character. All right, any questions so far? Everybody with me, what we're doing, how we computed the line trace start, the line trace end, and what we've got here. The other thing I want to do is I want to show you how to draw debug text. Let's actually create a little sequence node here just so that I can lay things out a little bit more cleanly. I am going to capture line trace start and end in some local variables. Let's do this. Let's call this one line trace start. We'll call this one line trace end. Will trace collide with player model? Yes, since I'm tracing on the visibility channel, it will collide with anything that is visible. You can also, there are a bunch of collision channels you can use. So you can say, hey, I only want to trace on things that collide with weapons, or hey, I only want to check for a collision with other players. You can do all sorts of traces, but visibility is like one of the simplest ones. So that's what we're going to be doing tonight. All right, so let's set our local variables here, and then we can just reuse these later. And I'm just going to go ahead and kill these lines because we don't need them. Great, we have that getting captured. We're going to neatly lay these out here. Look how clean the electronic nodes are, y'all. It's so nice. I like it a lot. All right, so then we want to draw our debug line, which we're going to put right here. And I will use a reroute node here just to make it a little neater. And we're going to reuse our start and end here that we just set above. The other thing I'm going to do is I'm going to save frequently, because the other night I had an Unreal crash and lost about an hour of work, and I definitely do not want that while we were on stream. It annoyed me off stream. It would be catastrophic on stream. All right, so we've got our line. Next thing I want to do is I want to put some text on the screen. So the way we're going to do that is with, I think it's actually just print string. Draw debug line and print string are development only functions, which means if you try and use these in a shipping game, it won't work, which is generally what you want, because this is just stuff to help us debug. This is not something we want to show to players ever. Seems like the origin of the line is the head at rest, which moves forward when walking, running. Does that mean all the math is only ever based on the model at rest? Does that cause difficulty when you are designing solutions that have to work with more complex animations? So the real answer is your start point can be anywhere in 3D space you want. We're just doing a very simple example here, Ziku. So we don't have to worry about, being exactly at the right position. We're just tracing forward. Print text, I believe, allows you to use a format string. Actually, I can show you that too. So hold on, let's do spray component debug information, or debugging enabled. We'll print that to the screen, but before we do that, let's print out, oops, I didn't mean to go that far with my reroute node. We're going to print out formatted information about our line trace. So let's create another one of these. Pull this one down here, and then we're going to make another one here. And I want to format text. I don't want draw text. I want format text. Format text, is that right? Okay, let's try here. Format text, there it is. Okay. And my format string is going to be line trace, and we are going to have it take in, y'all see this, is my text too small? We're going to have it take in line trace start, and we're going to have it draw an arrow to line trace end. And when I press enter here on my format string, it's going to give me 2 pins. I can then take my start and end, and it's going to force me to cast this to a string before I do that. So I can plug in like that. Same thing here. So we're now formatting text, and that will show us our line trace information as the actual XYZ values on our screen. And then we will print string that again here. Let me get it all wired up here. And again, we're going to use a little reroute node to make it a little cleaner. Something like that's probably okay. And let's move this back a hair. Perfect. And then this result just goes into our string. So the other thing that I need to change here is I want the duration to be 0, because we're, again, printing every frame. And also, I believe this has, print to screen and print to log. We do not want to print to log, and I'll show you why in a minute. We only want to print to screen because we're calling this every frame. So I think this is going to do what I want. Hopefully my editor's not crashing right now. It's doing something. We're going to hit compile and save here. So the basic version is text is for like localized strings that are going to show up in real games. And it's a lot more feature rich than just the debug string. Okay, so you see over, my editor's hanging. What's going on, little editor? Visual Studio is doing something. It shouldn't be doing anything. Okay, my computer just freaked out. It's fine. So y'all can see at the top left of our screen, we have spray component debugging enabled, and we have the line trace information. And as I move around, my X, Y, and Z change. No, the real way I debug Spy, if I'm actually doing hard debugging, is I set breakpoints and look around. But for the purposes of just seeing what's going on, having tooling like this is super useful, because sometimes visually it's much easier to see what's wrong rather than having to try and figure it out while paused at a breakpoint. I want to get rid of the lighting needs to be rebuilt warning, so I'm gonna build lighting here real quick. Yes, we built Ascent A on the very first Unreal stream. This is our attempt to pretend to be a level designer and block out Ascent A. All right, we have lighting getting built here. It's running. Come on. On a level this small, thankfully lighting is not very expensive to rebuild. On a bigger level, that can be a big operation. All right, now you can see that text is a little bit easier to see. We don't have the red anymore. And as we move around, the X, Y, and Z coordinates of our start and our end vector update, and then we draw that line in 3D space, which is the yellow visualization that we see. Now, I mentioned that we don't want to have a duration or print to log. First, let me show you what happens if I put a duration here. And this will make it abundantly clear why that's not what I want. See how it's flooding the screen? And that's because I'm updating it every frame. So I don't need to draw it every frame. I don't need to have a duration, rather, since I'm drawing it every frame. Right now, these are sticking around for 2 seconds and just flooding off. So let's change that back to a duration of 0. Same thing if I were to print to a log. If I look at my log here, if I clear this out and I've got print to log enabled, I'm flooding out my log. That's not what I want. So if it was like a one-time event, that would be totally fine. But since we're doing it every frame, we don't need to put that information there. Does that all make sense? Let me neaten this up a little bit. Okay, so now we have our line trace start and our line trace end. Right now, we are just debugging. Let's actually do our line trace and determine if we can hit something. So we're going to use our same get line trace start and end, and we're going to do a line trace call like we talked about before. And what did I say? I said by channel, right? Yeah, let's use by channel tonight. Okay, so again, start, end. Probably we're going to want a little bit more checking beyond just, hey, did you hit something? I think I actually want to pass on my hit result. So let's do that here. And that should be of type hit results. So we can pass that on, which is going to be useful. But before we do that, let's check, hey, did we even hit anything? And if the answer to did we even hit anything is no, then like we're done. We don't need to return anything. We know that we have failed out. I'll put that down here for now. If we did hit something, we have more work to do. Let's store this guy in a local variable. We'll call him local hit result. So if we hit something, we're going to store away our hit results so that we can inspect it in a couple places without it getting too confusing. And I still don't like the way this is positioned, so let's do this instead. Put a reroute node there. I recently upped my DPI on my mouse, and I'm not used to it. Okay, cool. So let's start looking at this hit result. Let's go ahead and split him out. I think one of the things that we want to know is whether or not we hit a static mesh. If we didn't hit a static mesh, I do not want to treat it as a hit. I did not update the command check. The math works out the same. I moved up to 1600 DPI and I divided my sensitivity by 4. So it works out the same. So I want to try, can I cast this to a static mesh component? Cast to static mesh component. We'll see if this works like I think it will. And then this guy has a receives decal method. If a static mesh does not receive decals, what that does is it makes it so that you can't put a decal on top of it. And this is useful because if you look at our button, you can no longer see our button. New is eating our button. That is not what we want, chat. We do not want New to eat our button. So we can come into our wall switch actor, and on his static mesh components, we can set receives decals to false. At which point you can see the button again. New is no longer eating the button. See, much better, much better. That's what we want. I'm also going to check it for the purposes of casting the spray. I'm not going to let you cast the spray if you are right on top of a static mesh that does not receive decals. Similarly, if you're not a static mesh, I'm not going to let you spray it. I'm just going to make you fail right out here and return false. And again, we're going to set up a little reroute node, keep this nice and neat. If it did succeed, then we're going to check our receives decals flag that we just talked about. If that fails, we're going to return nothing, just like before. You could also do things here like implement a cooldown system, have a max number of charges. There's like all sorts of good stuff you can do here, but like this is a pretty good starting point. All right, so at this point, we've confirmed that we have a hit. We've confirmed that the thing that we hit is a static mesh component, and we've confirmed that the static mesh component is configured to receive decals, which is the default. And in that case, we're going to return, yes, you can spray. And we are going to forward along our hit result so that we can do something with it in the function that is calling can spray. So there's no behavior change that's visible yet, but if we come to our debug information here, now what we can talk about is, hey, I want to make this line green if we have a valid target and red if we do not. So let's write the logic for that. Before we draw the debug line, let's call can spray. And again, we can reuse the trace start and end. Oh wait, I don't have to. I don't even have to do that. We already do that. Never mind. This is even easier than I thought. We'll just call can spray. I'm going to bump this up just a hair. Can spray. We're going to do a branch operation. If we can spray, then we are going to make it green. And if we cannot spray, we'll make it red. And that will give us a pretty good visualization, I think, of whether or not we're hitting a valid target that satisfies our criteria for being able to spray. Let's put that there. Bring this in just a little bit. Great. And we're going to copy all that. We're going to do the same thing here on the negative case. Wire that up, reroute it so that it's clean. Change green to red. And we're not doing anything with the hit result yet. We're just changing the color based on whether or not our line trace hit something. Okay, so you see we're red now, and when we walk up to a surface, we're green. Is that coming through okay on the stream? Y'all can see? My commitment to no blueprint spaghetti is admirable. Thank you, Gabe. I appreciate that. All right, so green and red, it's updating every frame nice and easy. Now, the thing I want to be clear about, what we're visualizing right now is not the actual line trace. We are casting a separate line trace on the exact same vector. So our line trace that we're casting is exactly identical to what we're visualizing, but the thing we're visualizing is not that same trace. And the reason that's relevant is because when we do this for real, we're not going to be doing it every single frame. We're only going to do it in response to player input. Right now, that's correct. I can't spray on ground because I am choosing to use the physical location of my pawn's head. I'm not using camera. I could use camera. And in fact, I can show you what that looks like. And the reason I didn't want to do that, if we use the camera, it will shoot backwards when I spin around in third person. But that's easy to do. Basically, instead of using the forward vector here, I wonder, I don't know what this is going to do, actually. Let's find out. Let's find out, chat. We're going to convert our rotator, or convert our rotation on the eye viewpoint to a vector, then multiply that, then add that. And I bet right now what we're going to see is the line trace goes wherever my camera's pointing, which is why you can't see it. Because it's a straight line down the dimension of my camera. You might be able to see there's like a dot. But this is not what we want. That would allow us to spray on the ground, though. I think in 3P, that's not what I want, though. Instead, what we would do is we would build out actual functionality around moving our character's head around. But yeah, and as our game gets more advanced, maybe we'll make it so you can tilt the head around. Okay, I think I've got it all working again here. Yeah, you can see the little dot. Exactly. All right, so let's do more debug drawing. Like we're going really deep on this, but that's just because I want to show you everything you can do here. The next thing I want to draw is I want to do more stuff when you get a hit. We're going to draw a box. Draw debug box. Okay. The center of that box is going to be the point where we hit. The extent, which is basically how far out the box goes. Let's set something small like 5 centimeters. And why does my Visual Studio keep opening? I think I'm like moving my mouse up to my monitor that's above the current one and accidentally popping that up. Again, we're going to stay at duration 0. We're going to do thickness 1. We have our hit result from before. Let's, I'm actually going to cache this in a local variable here real quick. Hit result. Can I do that? Is that going to work? Yeah, it does. Good. And so before our branch, I'm going to just store away. Actually, I don't want to do that. I don't want to store it away if we don't have a valid hit. I'm going to do this like so, and we'll move all of this out just a hair. Cool. Cool, cool, cool. And I could be really OCD and lay that out a little better. Great. So now we're going to take our hit result, and from our hit result, we're going to break it out into all of its component pieces, and we are going to draw at the hit result impact point. Hit result impact point is where our box is hitting the surface. You can see it now, that black box, right where it hits. Is that coming through on the stream? Yeah? All right, good stuff, good stuff. Okay, so we have almost all of the pieces that we need to do our spray here. The one thing that's missing is we got to get the rotation right for our little new guy here. Because if I were to say, turn him, let's just play with the rotator and see what happens. As I turn him around, he stretches and distorts, right? This is not what you want. It needs to be pointing the correct direction in order to project properly onto this surface. Otherwise, you're going to get all sorts of weird stuff going on here. That one actually looks not too bad. But anyways, we got to find the correct direction. And the way we're going to do that is we're going to use the normal of the surface that we hit. And a normal, so if you have a plane, the normal is the point on that plane that is perpendicular to the plane. Same thing on like any mesh, vertex normals. This is an example of what that looks like. You can see each little vertex here. There's the little red line coming off of it. That is the normal for that vertex, and it's perpendicular to that point on the surface. I've got another image here, which I'll show you that visualizes it similarly. Like on each face of this cube, the green line is the normal pointing off of that point in the cube. You can change those in the vertex data. Yes, exactly. So if you're doing 3D environment art, you're very familiar with this. If you're just like a lowly programmer like me, it comes up, but you know, I'm not messing with normals too often, so it's not a big deal for me. Let me get back to my correct view on stream here. All right, so one of the things that our hit result gives us is the impact normal and the hit result normal. I'd actually need to check what the difference is here, but I think what we want is probably the impact normal. This is going to give us that normal vector. So before we do anything, let's also draw that. This time, let's draw with an arrow. And our vector in this case, we're going to start from our hit impact point. And our end point is going to be, I think the normal is normalized, so it probably also has a total magnitude of 1. But what we're going to need here is vector addition. And we're going to need to scale our impact normal up. Let's make it always be 100 units. So we'll say our normal drawing, regardless of the max spray distance, is going to be 1 meter. So we add that to our starting point, and that's going to give us our end point here. I think that's going to be right. Again, I'm going to set my size to like 1. Let's make this one be yellow. And I'm going to make my thickness be 1 again. So this is basically just matching all of our other parameters. Again, we got some spaghetti. Let's clean it up. As y'all know how I feel about that. I'm actually gonna get rid of this line and we can draw from our reroute node here and just have 2 of them going in. Clean this up a little bit. You know, it's not perfect, but this is probably good enough. So let's see if that gives us a good visualization of our normal. Hey, there it is. So you can see that yellow line is perpendicular to the hit point. Doesn't matter where my character is standing. It just matters where on the surface we're hitting. And this should also work well with slopes and stuff. Let's make sure that's true. I've got a lot of like easy 90-degree scenarios here, but I want to show you what a normal is going to look like on a sloped surface. So let's drag in a static mesh that is sloped. Where is that? I think that is all under my super grid content, source meshes. And yeah, let's get a slope here. So I need it big enough that I can actually hit it from my character's head. We're going to make it super big here. Oops. Yeah, that should work. All right. Let's see if I don't spawn in it. There we go. Okay. So here you can see the normal is perpendicular to the surface still. So in this case, it's pointing up. Everybody with me on normals here. All right, let's make it actually do the spray. We're very close to having this implemented. But the cool thing here is like, so let's say we've implemented it and we have a bug. Like now we have a nice visualization for what the code is actually doing. And if you try and compute this from just like the debugger, all you're gonna get is that line trace XYZ stuff. And you can do a bunch of math and like figure out what's going on, but I'm not smart enough to do all that math and figure it out. I like having the visualization. And so it's pretty common that if you're working on stuff that's operating in 3D space, you can use all of this functionality that Unreal Engine provides to make it easier to figure out what the hell is actually going on. You would actually do the math instead of visually debugging, yeah. Yeah, being able to reason about this stuff geometrically makes your life a lot better. And then when you can draw it, it's really easy. You don't even have to reason about it. You can just be like, oh, what's it actually doing? All right, so let's go implement our request spray function out of all of the capabilities that we've built so far. If we can't spray, we're not going to do anything. If we can spray, then we're going to take our hit result. And from our hit result, we need our... well, before we do that, actually, we're going to spawn a decal. Spawn decal at location. And for now, we are just going to use our decal material that we created before. I think I called that spray. Yeah, spray decal material. Our decal size, we said that 64 by 64 looks good. Actually, like let's be good here. Let's make this a tunable. Spray decal size. So now a designer can come in here and change it up if they want to. It's going to be a vector. We need to compile so that we get defaults. Let's make it 64 by 64 by 64, and we can come tune that later. The location that we're going to spawn it at, we already talked about, is going to be our impact point. So that's where we're drawing the box right now. And then the rotation we can just make from our impact normal. And I think that's going to be rot from X. So in general, in local space on an object in Unreal, X is the forward vector. So this ought to do what we want. You can also set the lifespan. The lifespan controls whether it despawns or not. If it's 0, it will never despawn. If I set this to like 5 seconds, it'll despawn after 5 seconds. So let's do that for now. We'll set it to 5 seconds. All right, now the other piece that's missing right now is even though we've implemented the function to do the actual spraying, we haven't wired it up to input yet. So we did like a lightning tour of that last time. We're gonna do something similar here. Basically, I need to go into my project settings. I need to come to input and create an action here. So we have jump and interact from last time. I'm going to call this action spray. And I want to bind it to my T key by default. Oops, not S. I actually wanted T. There we go. All right, so that is now bound. Then the next piece is I need to have my, that's my game mode. I needed my controller, I think. Let's save everything before the editor crashes. We're gonna, what did I just do? No, I do not want to open GPA, thank you. Okay, so I want to go into my controller here. And if we press the, what did I call it? The spray. Yeah. Input action spray. If I press that key, I want to get my controlled pawn, which is the thing that is controlled by our controller. And then on our pawn, I want to find component. Maybe it's called get component by class. That's what I'm looking for. If it has a spray component, EP spray component, then we're going to do a valid check. And if it's valid, we are going to request a spray. So now any actor, any controlled pawn that we create that has a spray component now has the capability to spray. And the thing that's cool about this is I didn't have to write any code in our character itself. I just added this component to it. So if I want to take away the ability to spray, I just delete this component. If I want to make a super cool vehicle that can spray, I just put that component there as well. Very easy. Now, if I come up against a wall and press T, we should spray, and we do. Right now, we've only got the potato spray, and I think we said we've got the 5-second fall off. Oh, the other thing I'll show you, because somebody asked about this. That spray exists in 3D space, and so when the mesh it's projected on goes away, it will disappear, but when the mesh comes back, it will also come back. Let me take away our lifespan so that it sticks around. I might have needed to compile, we'll see. All right, so you can see that part of new goes away, but as soon as I bring the door back, he comes back. And yeah, we can spam spray. All right, well, like this is pretty cool, right? This is all pretty basic, and let's make sure that what we said about this works as well. Yeah, so you can see we automatically rotate based on the normal of the plane that we're spraying onto. So it'll work on sloped surfaces. Similarly, if we had implemented the ability for our character to look down, we could spray the floor and everything would just work. This also is going to have the same bug that you have in Valorant, which is if you do it on the edge, it stretches, right? Because we're using the normal for the surface that we're hitting, not the normal over here. Unreal has another kind of decal called a mesh decal that is more complicated and can wrap corners, but I have never used it for anything. But the engine does have some tech for scenarios going around corners if you really want to get into it. But yeah, similarly here, if I think I can probably go over the top of the box and we can stretch out his hair. But your mental model for this is like, hey, you just have a can of spray paint. And like, if you fire your can of spray paint right here, yeah, it's going to streak on the edge. And as you mentioned, the amount that it streaks is going to be determined by the depth of the decal. So if we come to our new here that is still just sitting in the world, and if we bring him into a position where he reproduces that behavior, if I come here and what is that? Is that my Y dimension? If I cut this in half, oh, it wasn't the Y dimension. What dimension is that? Maybe it's this one. No, this one. So if I cut the X dimension in half, the amount of streaking is going to shrink as well. So you do have some control over that with basic decals. Do Valorant spray have a emissive on their material? I'm actually not sure, Spy. I would need to check. All right, well, now we can spray, but I don't like that we can only spray new eating potatoes. As y'all know, this is like my worst emote, and it never comes up in actual gameplay because I never miss a shot. You know, just stone cold killer every time. Headshot, tap, tap, tap. Never need that potato emote. Let's make a spray randomizer, right? So right now we're just spawning a decal using our fixed material. Instead, let's have it so that we can have a set of textures here. And let's make sure I select the right type today, because we struggled with that on the last stream. I think what I need here is just a basic texture. Just a texture. Yes. And we need an array of them. All right. So let's call this array spray textures. We're going to compile, and hopefully the editor's not going to crash. We're going to make this configurable. I think we have 7 emotes. So let's have a 7-slot array, and let's just load it all up. So we got that aim. We've got exercise. We've got the heart. We've got hype. Peak. I forgot hype. Let's fix that. This is actually the most tedious part of this. It's just like loading our array with all of the different types that we need. That's okay. All right. Cool. So we've now got our spray textures here, and we are going to, I think it's set material parameter. What's it called? Let's promote this to a variable. We'll call that decal material. Sure, that's fine. Spray decal material. I believe we previously set a parameter. What's it called? Set texture. All right, let's try this. We're gonna get rid of context sensitive. Set texture parameter. That's on a retainer box. That's not right. Set texture parameter value. This is what I wanted. Context sensitive wasn't finding it. So sometimes if you don't have the right object selected, Blueprint's trying to help you by like not showing you stuff it thinks you don't want, but I actually did want it here. So that's what my problem was. All right, and if we look at our material, let me see what we named that value. I think this is over in our art folder. It's loading up. Our shaders are recompiling. Spray texture is what we called it. Okay. So what we want to do is we want to change the value used for spray texture. And I think I want to pick a random one. What up, Saran? Yeah, we spraying. Let's see. Oh, this is cool. I didn't actually know. A Blueprint has a random, select a random value from an array helper, which it makes sense they would have, but I was about to be like, yeah, let's get a random int between 0 and the size of the array, but we don't have to do that. Unreal did that for us. Hell yeah. Cool. All right. So it gives us an index. We don't care about that. It also gives us the item, which is what we do care about. So our target, I see we need a dynamic material instance. So let's do that. Dynamic material instance. I actually don't need this variable anymore. Let's go ahead and get rid of it here. It says it's in use. I don't think it's in use. It's fine. We're going to say m spray decal. Then on our dynamic material instance, we are going to set texture parameter value to a random texture. And we, instead of doing all of this stuff, we are going to use our new dynamic material instance. Okay, we got to fix the spaghetti though. Still have a little bit of spaghetti, but it's less with electronic nodes, and that's what's important, y'all. Turn on storage sense. No, I don't want to do that. Leave me alone, Windows. I'll come to you, Windows. All right, let's put this over here. So we're creating our material instance. We are setting the texture to a random texture from our array that we just created, which has all of our individual textures. And then we are going to spawn a decal, and we need to use the material instance that we just created. And I believe now, chat, we're going to get a random spray every time. Let's check it out. Oh, we got the aim spray. I hit it twice. We got a potato. We got a heart. We got a potato again. We got another heart. All right, let's get that aim one. We got the rage. We got our peak heart again. You'll recall we also made it so that you can't spray over the button. So when I do this, you can see the button draws on top of our decal, which is what we want. Hey, there's our aim one. So everything's good. The last thing I think I want to do here is set the lifespan to 5 seconds because I don't want an infinite number of them. I think that might be everything that I want to show y'all in this one. Any questions? Any questions, y'all? I can spray. They'll clean themselves up. This one that I left in the world at the start is not going to clean itself up because I didn't cast it dynamically. But all the other ones are just going to clean up. Right? New spray in Valorant win. Maybe I could sneak that in. Make that a battle pass reward. That'd be pretty cool. You missed it. Do it all again. How do you know all the blueprints you need to use? Experience. like when you're learning, right? Like the point of this stream is basically to tell you that line traces exist and to tell you that debug drawing exists. When you're starting out, probably the hardest thing is figuring out what to Google for. But like once you have kind of a good foundation of like, hey, these are the individual building blocks, you can figure it out. How does the GUI work in the lobby? I'm going to save that for another stream. I do want to do GUI. So I thought about with this one, I think the next topic I want to cover is I want to take the spray component that we've built here. I want to implement cooldowns and recharging, which will teach us about timers. And I think that will also give us a good opportunity. Instead of using this debugging stuff that we've used, we can build actual UI for it. In fact, you know, I mentioned that our debugging doesn't actually do anything for us, right? Like it just makes it easy for us to see what's going on. But I'll confirm that now, right? I can still spray here. All of my magic lines are gone. If I'm standing in the middle of the map and I press my T key, I don't spray. So it's all working the way we expect. Any other questions? Make the spray a projectile. We could do that. That would be more complicated. Probably what we would do there is we would have the spray itself wouldn't be a projectile. We would shoot a projectile, and when the projectile collided with a surface, we would then spawn a spray at that point. So, you know, another use, you know, we did this with sprays, but let me fire up Valorant, actually. All right, first I'm going to close this out. I'm going to save everything. I'm going to fire up Valorant. I'm going to show you another use case where we can do something very similar to what we just did here, which is bullet impact decals. Like it's the same basic idea. Implement sprays. Cool. All right, let me fire up the game and I'll show you what I'm talking about. No, this is Console Z. I'm actually though I'm soon going to move over to the Microsoft Terminal. I really like the Microsoft Terminal, but I've used Console Z for years and I haven't updated on this machine. So as soon as Valorant starts, I'll show you. But yeah, bullet impacts are just decals. Is it a private repo? Yes, it's a private repo on my computer and on my network. It's not on the internet. At some point we might, if we do a bigger game project, I can probably make it public. But for like these little toy projects, I'm not really doing it up to a standard where I'm comfortable just like throwing it on the internet. I would want to put a little more thought into it, I think. All right, so let's go into the range here. So the like one gameplay feature that I actually implemented, y'all can be proud of me here, but you know the little shooting target in the range where you can set the distance right over here. See those yellow circles? Those are just decals. So when you have a hit impact based on the material that we're targeting, we spawn a decal, right? So like if it's unpenetrable, you get like this little impression. But if you got like the Odin and you can go through a corner, right? Like we spawn a different decal. So like this is a real world example of where like what we just built is super relevant. And you'll also notice over time, or if I create too many of them, the old ones start despawning. So like we literally just implemented the tech for bullet decals. Pretty cool, right? Like some of these basic concepts allow you to do lots of cool stuff right out of the gate. You see hours of immaculate blueprints that could be framed, followed by not out of our public. How does the system for keybinds work? So, I mean, we talked about in our project settings, we can configure input, right? We did that. And to implement keybinds, you basically just build some UI that changes the value of those binds in your local settings. I didn't do all the bullet decals, Nick. I specifically did the shooting range bullet decal. That was my pet project. I saw it in some other game and I talked to Carney and I'm like, Carney, let's build that. And so I built a new physical material and I built some programmer art that is still used in the game. It's just that yellow circle. And then I did like 6 hours of plumbing through the various systems to teach the bullet impact system about our shooting range physical material that we didn't plan for. So input, right? Like if you go to your project settings and if you come to input, these are the actions I've defined. I can choose to expose these action mappings in a piece of UI and then allow a player to rebind them in their local settings. So like me setting this to T, it's just the default. We can change it to whatever the heck we want. And so maybe we'll do that in another stream. We can build out the UI for that. But yeah. What else, y'all? Any other questions, or do we wrap on Unreal and play some Valorant? Cool. I'm gonna get in there then. That was your favorite part of the practice range? I'm happy to hear that. So another feature that I want to implement that I haven't implemented because it's like slightly hard, like it's not real hard, but it's like slightly annoying and the value isn't clear. But a feature that I'm going to build someday, if I ever have a project to do like a little, or if I ever have time to do a little hackathon, is I want to make it so that the color on that material changes every time you start a new spray. So you could imagine you're sitting here spraying with your Vandal and you do like 4 shots and then 3 shots and then 4 shots. And like the first time it's yellow, then it's like blue, then it's like green. We just like pick a random color for each spray. And so you can really visualize your spray patterns as they overlay one another. But it'd be lightly annoying to implement in our current system, not because it's hard to implement in the abstract. It just would take a while. Do I plan on doing networking things? You noticed almost everything in Val is server initiated. I'm curious if there are any other accurate approaches involving prediction. So we have lots of things that predict on the client. For example, I need to turn off infinite ammo.